Hey guys, welcome back. Now I'm gonna start working on a new sensor that is TSL2561. It's a light sensor. And to gain more knowledge about this sensor, let's have a look over the website that is controleverything.com, and here search on for this sensor that is TSL2561. And here we go. As you can see, it's a light-to-digital converter 16-bit programmable gain I2C module, and these are some of its features. You can also purchase the sensor from here. Also in this video, I will be interfacing the light sensor TSL2561 with the BeagleBone black, and the software platform will be C language code. And to get the code, go to resource tab, and here comes the C code sample as you can see. After that, you can also download the code from this as a zip file. You can also have the opportunity to download the code from github.com, and the repository there is Control Everything Community. Let's have a look over the hardware connections now. Let's watch this. Well, for the connection setup, first of all, the requirement is the BeagleBone black, which you are able to see on my screen, and this here is an I2C shield. This is available on the website controleverything.com, and we are using it to make connections easier with other I2C devices. So we use it. So after that, we have to gently place this I2C shield over the BeagleBone black, and then we have to press it. And now we need our sensor, that's the light sensor TSL2561, and this here is a connecting cable. Make the connection among the sensor and the cable, and make sure that the brown wire of the cable is connected to the ground terminal of the sensor, and for the same reason to the I2C shield. Now we need to power up the BeagleBone black, and there are two things we require for that. And first of all, we need a mini USB cable just like this, and gently insert it over here, this jack. And next we need to power up, for that we require an adapter of 5-volt supply, which you can see, and gently insert it over this power jack. Next we need to provide an internet connection, and there are two things. Either you can use first of all an Ethernet or a LAN cable. You can gently insert it over there, Ethernet jack, and second you can also use a wireless Nano USB adapter. Now as we are done with the connections part, we need to have a look upon the code, C code. For the interfacing part, we need to have a look over C code, and to get there we have to log into github.com, and then here we have to search for the repository that is Control Everything Community, and then here type in 2561 TSL. As you can see, it's a digital light sensor, and here comes the C code. Let's have a look over the instructions first. As you can see, first of all, we need to set up and connect the BeagleBone black, and all the relevant information and the steps to install it are provided on the link that is beagleboard.org. After that, we can download or git pull the code in the BeagleBone black, and we have to compile the code. This is the command to compile, and this is to run the C code. Note it down. Then get back to C code, and as you observe, it's a .c extension file, and you notice that we have included some of the header files here. In the void main function, we have created an I2C bus, which you can see, and we have to check whether the bus is there or not. Then we have to check for I2C device and address of the sensor, that is 0x39. Now in the writing section part, we are going to select control register 0x00 or with command register 0x80, and we are going to send the command for power on mode, that is 0x03. Here comes the writing section for this part. Then we have to select the timing register 0x01 or with command register 0x80, and we are going to send the command for nominal integration time, that is 402 millisecond goes for 0x02. Writing command is here. Then we have a sleep or delay of 1 second, and after that we are going for the reading section, where we are going to read 4 bytes of data from the register 0x03 0C, pardon me, 0C, or with command register 0x80, and it's a channel 0 and channel 1 data. And here comes the command for that, and as you can see, here comes the conversion of the data, which is according to the details provided for the datasheet TSL2561. At the very end of our code, we have the output to be displayed on the screen, which you can see as the full spectrum, infrared value, and the visible value, and all the values are in the unit of lux. So this is the end of our code. Now let's have a look over the practicality of this code, and let's see how it works. Now looking at the practicality of this sensor in the working environment section, The first step is to copy this entire code as you can see on my screen, and then we have to open up the terminal for the BeagleBone Black, and here we have to create a new file. As you can see, it's a .c extension file, and here we have to paste the entire code, and at last we have to save it. After that, this is the command as you can see on my screen. This is for the compilation process, and you have already seen this command in the instructions part. And let's see what we got. We have the compilation successful, and after that we have to build and run this code and see what we got. We have the full spectrum, IR plus visible, infrared, and the visible. As you can see, all the values are in lux, and when I run again the command, you can notice the change in the all three values is almost negligible, because there is no interference regarding the intensity of light falling onto the surface of the sensor. But when I bring some source over the sensor, you can see the decrease in all the three values for full spectrum, IR, and visible. But when I place some light source over to the sensor, there is an increase which is perfectly visible onto the screen for full spectrum, IR, and visible value, which is in lux. So this is how the sensor works. Now let's have a look over the benefits and the applications. The TSL2561 is a light-to-digital converter that transforms light intensity to a digital signal output capable of direct I2C or SMBus interface. This device combines one broadband photodiode and one infrared responding photodiode on a single CMOS integrated circuit capable of providing a near-photopic response over an effective 20-bit dynamic range. It's applicable in a lot of applications like notebook, tablets, PCs, LCD monitors, light control, street light control, security lighting, sunlight harvesting, machine version, and a lot more. This sensor is available on the website controleverything.com, and you can purchase it from there. Also, you can have the code from there. The resource tab is there, and you can download the code as a zip file. Now you can also have the code from github.com, and the repository there is Control Everything Community. In the end, I would just like to make it clear that if you are left without fully understanding any part of this video or sensor, you can have your queries on controleverything.com, and you can post your comments on community page of this website. For blogs and articles, you have a look over instructables.com. You can go there, and also to subscribe more video tutorials like this, you can have a look over our YouTube channel. So I hope you enjoyed this video, and thanks a lot for watching.